So for this statistics project, I wanted to do some research and analysis on a data set provided by Yelp every year. So they take a subset of all of their reviews and they post them in this large data set, and it totals to about 7 million reviews. So I had to do kind of some interesting things to process all this data, and I did it in a Jupyter notebook with Python. I'll post all of my code online so you can see that if you're interested, as well as all the graphs that I've created. So what I wanted to see was the relationship between the data provided in each review. So each review has a text review associated with it and a rating for that business of 1 to 5. Um, and I wanted to see, given the number of positive and negative words used in our text review, what can we expect the probability of our rating to be? So I found this data set or two data sets online of positive and negative words, and this is provided by Hu et al. At the University of Washington, I believe. So there's all of these positive words found in this data set, and then negative words as well. So I iterated over every review and counted how many positive and negative words were there. And then given that, I could calculate the conditional probability that our rating would be such. So I'll kind of take a step back here and do some broad overview of the data set and what we actually see, and then we'll go more in depth on those conditional probabilities. So first of all, the first thing I'll point out is that a vast majority of reviews are positive. We can see that in our data set, 80.4% of reviews use more positive words than negative words. Only 13% use more negative words than positive words. And what we really want to do is we want to compare this pie chart to this one here. So this one on the left represents our text reviews and the positive and negative words in that text review. The one on the right is our integer rating from 1 to 5. So we can see that 66% of reviews are rated higher than a 3. We consider 3 kind of the midpoint, right? Because you could review it above that, a 4 or a 5, or below that, or a 1 or a 2. So 3 is kind of our middle point here, a neutral review, you might say. And only 23% of reviews were less than 3. What I find interesting about this is that there are more negatively reviewed restaurants or businesses altogether than there are negatively rated restaurants by words. So we might find, that means we're finding reviews that are rated either a 1 or a 2, but they still use more positive words than negative words. One possibility for this would be our lack of checking for negation. So a review that gives a business 1 star might repeat several times that this business was not good. We're not checking for that accurately. So we would see that this review uses the word good, and we would determine that that means that this is a positive word. But we would not actually account for that not in front of that. So that might be one possibility for why we are seeing this. But onward, a bit of a review on what we see for the amount of words counted for a given rating. So starting with this first one here, this is the number of positive words counted by rating for the first 1,000 elements in our data set. So we can see a slight relation between, we find more positive words as we increase our rating. This isn't super strong here. We still see, like we were saying before, a lot of positive words even when we are rating something low, like a 1. So it's rather flat, and we see the same relationship when we're looking at negative words. It's much more flat. But what gets interesting is when you start finding the difference between positive and negative words, right? So like I was saying, there are just overall more positive than negative words. But when you find the difference between the two in a review, you start to see a more progressive relationship. So we see that these reviews, as we subtract the two, and we weigh the positive words as a positive and the negative words as a negative, subtracting negative from positive, we see that as we approach 5, we're actually increasing the number of the number of I'm sorry, the difference between these two. So there's more positive to negative words as we approach 5. So that was kind of interesting there. And now I started breaking it down into actual probabilities. So I'll start with the most basic one, the probability of x, where x, let's say x is our rating, and so that would be in the sequence 1 to 5. And what we see is, like I was saying before, most reviews are either a 4 or a 5, because people tend to be more biased towards places that they enjoy. And I think people try and avoid places that they don't think they would enjoy. So we see more positive reviews, or positive ratings, I should say. However, now we start to get into the conditional probabilities, and this is where it gets interesting. So the conditional probability that there are more positive than negative words gives us a higher probability that there will be 5 stars and a higher probability that there will be 4 stars, which is exactly what we would expect. Then we can see that the probability that the rating is 1 goes way down, way down. Same for 2, it goes down as well. So this is exactly what we would expect. But like I was saying before, how do we know that this isn't just because people review more 4 or 5 star places? And that's because we can see the exact opposite relationship when there are more negative words than positive words. 62% of these are rated with 1 star, which is fascinating. And only 5% are rated with a 5 star that use more negative words than positive words. And then we see when it's neutral, when there are as many positive as negative words, then we're starting to see that it's more of a uniform distribution, where they're more equal. You can see that the rating of 1 stars is 33%, which is the highest here, but the rest are rather flat. This 33%, this outlier here, I bet this has to do with that negation problem I was mentioning earlier. So now I took these probabilities and graphed them, so you can actually see how these are changing. So the total rating distribution, the probability of X without any conditional, is mostly 5s and 4-star reviews. However, then we look at the probability of X star ratings given that there are more positive than negative reviews, and we see a pretty steep incline towards 5-star reviews. And the exact opposite is seen when there are more negative than positive reviews. Our uniform distribution is more flat. So after I figured this out, I then wanted to consider, what is our conditional probability for any value of P and N? So if we set P and N to random variables, or say that W, our random variable W, is equal to the difference between P and N, how can we see that changing over time? And I actually created a little animation to show that here. So this is my code here, and I'll scroll down to the bottom where I have this. And this shows how our probabilities are changing as we fluctuate between the difference of P and N. So as there are much more negative reviews than positive reviews, you can see it's almost all 1 stars. But then we approach 0 and it flips. So we get more positive reviews, and then we start seeing 5 increasing. And then as positive reviews approach a really high value and negatives go really low, we see more and more 5 stars. So watch as this approaches 0 how it flips here. Right about 0, we see a flip in association here, which is super fascinating. Yeah, so that's what I worked on. I will post all of this online as a blog post as well, so you can see the code and analysis that I did. But thanks for watching.